L'Hopital's rule, part 2. Recall that L'Hopital's rule says that if your numerator and denominator are both going to 0, in order to find the limit, you can find the limit of the derivative of the numerator divided by the derivative of the denominator. And you can also use L'Hopital's rule if both the numerator and the denominator are going to infinity. Let's look at an example. As x approaches 0 from the right, cotangent is getting larger and larger without bound. And 1 over x is getting larger and larger without bound. So we can use L'Hopital's rule. We have the indeterminate form infinity over infinity. However, oftentimes we want to change the way a problem is presented. As I said, this has the indeterminate form of infinity over infinity, allowing us to use L'Hopital. But notice that the quotient can be rewritten as x over tangent x. And so even though L'Hopital's rule can be used with how it's written, the limit using the simplified form of the quotient, well, that also has an indeterminate form that is allowed by L'Hopital's rule. And in fact, it's a form that is much, much easier to work with. So just because you can use L'Hopital's rule right off the bat, you might not want to. You might want to say, well, what happens if I simplify? In this case, when I simplified, I still can use L'Hopital's rule. All right, so these two limits are the same. This is just the quotient being simplified. And so use L'Hopital's rule. And the derivative of tangent x is secant squared, and the derivative of x is equal to 1. Now 1 over secant squared, that's just equal to cosine squared. So I can just, at this point, find the limit with direct evaluation. And when I do that, I get 1. In this next problem, the conditions of L'Hopital's rule are not met. It is of the indeterminate form 0 times infinity. What we're going to need to do is rewrite the limit so that we can use L'Hopital's rule. So let's do that. If I rewrite x cosecant x as x over sine x, if I do it that way, then I have a quotient where both the numerator and the denominator are going to 0. So we have the form 0 over 0 allowed by L'Hopital's rule, and we take the derivative of the top and the bottom, and we evaluate the limit directly. So this indeterminate form, 0 times infinity, that has a limit of 1. Now, this limit is of the indeterminate form infinity minus infinity, very dangerous to work with. We need to rewrite the limit so that we are able to use L'Hopital's rule. Infinity minus infinity is not 0. It's an indeterminate form, meaning it could be anything. So we want to know in this situation what the limit is. So we're going to rewrite it. And when we're just playing around with the expression, how about if we multiply it by cosine x over cosine x? When we distribute the cosine x that's in the numerator, then we get this. Now what's tangent x times cosine x? It's equal to sine x, isn't it? And what's secant x times cosine x? That's equal to 1, isn't it? And so it simplifies very nicely to this. Now, is this of a form that you can use L'Hopital's rule? Sure. It's of the form 0 over 0. Both the numerator and the denominator are going to 0. And so we go ahead and take the derivative of the numerator and the denominator. And once we take the derivative of the numerator and the denominator, we see that the limit can be found directly. The cosine of pi over 2 is equal to 0, and the cosine of negative sine of pi over 2 is equal to negative 1. So the limit, which has the indeterminate form infinity minus infinity, is found to converge to 0. A couple of things I want to point out. First of all, L'Hopital's rule is not the quotient rule. If you're trying to find the derivative of f over g, you have to use the quotient rule. L'Hopital's rule is not the quotient rule. You only use L'Hopital's rule when you're trying to find the derivative, and you have to have the indeterminate form 0 over 0 or infinity over infinity. So, and that's my second point. To use L'Hopital's rule, the given limit must involve or be rewritten to involve the indeterminate form 0 over 0 or infinity over infinity. Now let's just look at these two limits. Check that the conditions of L'Hopital's rule are met. In the first case, no. L'Hopital's rule, the conditions are not met because I have a quotient that has the form 0 over 1. And in fact, this first limit can be found with direct evaluation. The numerator is going to 0. The denominator is not going to 0. The denominator is going to 1. And 0 over 1 is just 0. Now, how about the second one? The second one, yeah. This has the form 0 over 0, and so I can use L'Hopital's rule, and I get that the limit is equal to 1. So you should always check to see whether or not L'Hopital's rule can be used. Take care, and have a great day.